In this module, we're specifically going to look at how to design and execute a roasting profile with a Giesen coffee roasting machine. So first and for all, what is a profile, a roasting profile? Is of course, a profile that describes how the coffee was roasted over a certain time using certain temperature settings. And to accomplish a roasting profile, there are machine settings to incorporate, and there are some environmental factors that will have an influence on the profile. So on a Giesen roasting machine, and I think this is where Giesen machines are kind of unique, you have a multitude of parameters to your disposal to create profiles. And so from a generic perspective, when we are creating profiles, we need to understand how to regulate the heat output of the burner, which of course your Giesen machine has. Ideally, you need to be able to regulate the airflow and be able to control that in a certain way. And then ideally, you also want to be able to create a certain profile using your drum revolutions. Now, Giesen machines have all these tools to their disposal. First of all, when we're talking about heat output of the roaster, the first step in defining a heat output setting is when you start charging the coffee into the roaster, the charge temperature. And then the second step, the second aspect in the heat output is, what type of profile for your rate of rise are you going to look at? Rate of rise is basically the bean temperature increase over time, usually every 30 seconds, and how that increase behaves over time. So during the roasting process, you can create a certain curve for that rate of rise. And with your Giesen machine, as I mentioned, you also have this possibility to do air pressure profiling. This basically is a very, very unique feature that other roasting machines simply don't have. With the Giesen machine, we can basically set a specific set point for the pressure during the roasting, and I can change that set point during roasting. And then last but not least, the drum revolutions, the RPMs, we can also set these to the liking, to the requirements of your profile. The environmental factors, how do those influence the roasting process? So the ambient temperature, the ambient air pressure, as well as the relative humidity of the air, those three factors influence the roasting process. The ambient temperature, of course, the air that is sitting in your roasting room, in your roasting environments, that air is usually the air intake of the roaster. And so if that air has a higher temperature, then that will influence your roasting process. The barometric pressure, the air pressure basically, can vary with the elevation of where your roasting warehouse is, or it can vary with weather conditions. And so this barometric pressure has an influence. If I'm roasting coffee in, let's say, Addis Ababa, which sits at 2,600 meters elevation, then the roasting in such a condition will be distinctly different from roasting at a lower elevation. Like here at Boot Coffee Campus, I'm at sea level. And so, last but not least, the relative humidity. If my relative humidity is very low, so let's say I have 30% relative humidity, then that of course will create a different roasting process than if I'm at 70% relative humidity. And so all these factors combined, they provide you, the roaster, the opportunity to create very unique roasting profiles. And with roasting profiles, we're of course looking for consistency, for repeatability. And ultimately, you're striving through your roasting profile to create kind of the signature for your roasting style. And you as a master roaster, you're very well able to do that with your Giesen roasting machine. And I'm going to cover specific details of that. I'm here with the wonderful WPG1 sample roaster, and for the explanation of roast profiling on Giesen machines, the beauty of the whole Giesen lineup is that the control panel on this sample roaster and the overall settings of that control panel is basically identical to any of the other Giesen machines in the roasting lineup of Giesen. So I'm going to specifically discuss settings that you can apply, that you can use to create unique roasting profiles, regardless whether you're using this machine, the WPG1 or a W1A or a W6 or a W15 or a bigger roasting machine of the Giesen family. So here is a view of the control panel of the Giesen machines, and I'm just going to explain each of these functions. This is to initiate a timer, this is to start a light, this is to basically set a set point, a temperature set point. Right now it's just 383, and I can increase that to, for example, 392. And that set point is very much like a thermostat set point. I can also push this out of the way to allow the machine to more use that as a safety cutoff. I could set it at 450 degrees Fahrenheit, and in that way it will not really interfere with the roasting process. Then on the other side here I have the burner settings. I can go from off to 1% to 2%. I can keep this pressed and then go to 45%, and then I can go to 80%. So that's the first screen. Then the second screen is this one here. Here I can set the air pressure, and the air pressure is basically defined as the difference between the air going out versus the air coming in, and the air pressure is basically an expression of the relative under pressure, the relative vacuum. So right now this set point is at 140 PA. PA is Pascal, and I can set this to 120, for example. And then on the other side here we have drum revolution. Right now it's set at 50 Hertz. That's indicative for a certain number of rotations per minute. This corresponds closely to 48, 49 revolutions per minute. And I can also decrease this, or easily increase this. And so the beauty of the Giesen roast profiling system, which is the software that Giesen has been designing over the years, is that you can record these profiles while you're roasting and then repeat them, play them later on, so that you can have a consistent repeatability of your roasting process. So let's do a roast using a roasting profile, and the first step in executing a roasting profile is basically designing one. And how do we design this? By basically looking at and discussing what parameters we're going to use and how during this roasting process, during this roasting profile. So right now I've been preheating my machine, and I'm going to allow the machine to get to the right starting point in order to initiate this profile. And so that's why I'm now put my thermostat to a really low setting, just to allow the machine to cool down in order to initiate a roasting process using a so-called heat soak. And what we're going to do is, as soon as we reach 325 degrees air temperature, at that moment I want to initiate a roast with the burner off. And then I'm going to turn on the burners as soon as the beans start taking up heat, and that's at the turnaround point. So right now the air temperature is 393, coming down. The bean temperature probe is measuring 363. The rate of rise is now at -11, and my flames are off. It's basically the preparation for the process we're going to do. And here we're going to start at 120 PA, and we're going to keep this drum setting the same. My advice to you is not to tinker from the get-go with the drum rotation setting. I recommend to start using this at 50 Hertz. And once you're starting to become more familiar with the Giesen machine settings and with all the options, then you can design curves around the drum rotation. So during this roast, we will start at 120 PA, and at around the 7-minute mark, I will increase to 160 PA. So we're starting to gradually approach the point where we can get ready to roast. A little bit about the coffee that we're using today. This is a Mexican coffee, Hacienda. It's a great coffee for doing profiling exercises. It's a medium hard bean coffee of around 62 kilos per hectoliter. And it's a great coffee for profiling. Very nice coffee in general. And I'm going to charge the coffee into the roaster or into the loading hopper of the roaster when I'm getting relatively close to this starting point. So right now we are air temperature 341. I want to start at 325, so we'll get our coffee ready. And so what is heat soak? Heat soak is basically allowing the beans to absorb the heat, the radiant heat of the roaster, without adding heat. So basically with the burners off, and to allow the coffee gradually pick up the heat from the machine before we really start putting on the flames. The beans first have to go through their turnaround point, which is basically the point where the beans start absorbing heat. That's also the point where my rate of rise becomes positive. And so now we will start the roast. I say start here, and time is ticking, and now I'm initiating this roast. And during this turnaround point, or during this first period leading to the turnaround point, we will see, as we see, that the rate of rise is very negative, and it will gradually become a positive number. At that point, we are basically passing through the turnaround point. My air temperature is 296. So my bean temperature, you can see, is 177, still coming down. And so at the point where the bean temperature starts to go up, that's also where my rate of rise starts going up. And now I'm going to put the thermostat setting out of the way. Let's put it at 474. And now my rate of rise becomes positive. So now this profile we initiate at 80% heat, which should be more than enough to start this roast. So we're now almost 2 minutes underway. My rate of rise is around 16, 80% flame output. So the heat output of the burners is at 80% of their maximum capacity. And my air temperature is 343, my mean temperature is 215. And so at this point, I'm not going to interfere with the process. We're now passing through 2.5 minutes, and we're now basically in the drying phase. The beans are letting go of their moisture. Moisture is evaporating, and that vapor starts to create pressure inside the cellular structure of the coffee, and that pressure starts to induce a whole set of chemical changes. Wow, that's a mouthful of words. And all those chemical changes that are now going to get started soon, being one of them the Maillard reactions, those start to induce a process that's also caramelization of sugars. And during all this process, amazing things are happening from a chemistry perspective. Roasting is fascinating, especially the underlying processes. So we're now at 3 minutes 15 seconds. My rate of rise is 14. Bean temperature is 248, and I'm still maintaining the pace that I'm at right now. When I'm approaching 280 degrees Fahrenheit bean temperature, that's when these Maillard reactions are really starting to peak. And at that point, I'm going to gradually reduce my burner setting. My first reduction will be from 80% to 60%. And then every 20 degrees, I will make an adjustment. And then where I also then have to think about is the PA, the air pressure setting. I'm going to increase that from 120 to 160. That was the plan. And what does that do? That basically creates more airflow, but it keeps that airflow set at the set point that I basically determined. And that's the cool thing. The increase in airflow will elevate the perceived acidity in the coffee. So now we are at 4 minutes and 30 seconds. We are at 16 degrees rate of rise still. And so now my aim should be, my bean temperature is just beyond 280. And so now I'm going to reduce from 80 to 60. And really my aim is now to see a decrease in my rate of rise. If that decrease is not sufficient enough, then I will reduce my burner setting more so that my rate of rise can go from that 16 points down to 12, down to 10, down to 8. And gradually I want to see a decrease of my rate of rise during the roasting process. My rate of rise is 14 now. It's gradually coming down. My bean temperature is 311. And I'm taking my burner setting down to 40 now. I'm ready to start making major adjustments in my heat output. Let's look at the sample of this coffee. I hope you can see that on camera. So here, if I make an assessment of these coffees, they're kind of getting a hay-like smell. It creates the perception of like a kind of a sweet honey type of smell. So now our rate of rise is at 11. We are now approaching that 7-minute mark where I wanted to increase the PA. I'm actually going to do that right now. I'm going to also make another burner adjustment. Let's do that first to 20%. My bean temperature now is 338. And I'm going to increase my PA to 160. And I can hear now the fan of the machine working a little bit harder. And you know, more airflow at this stage will do two things. It might accelerate the roasting process initially, but because I've been turning down the burner, it will also slow down the roasting process. So it first accelerates a little bit, but then it slows it down. And my bean temperature is now at 356. I'm going to reduce my burner setting even more to 10%. So my rate of rise now is 10, and I hope to see that coming down even more. I'm going to inspect my beans. So I get a faint type of coffee fragrance. I think we're getting very close to the start of the first crack. I'm going to reduce my burner setting even more to 5%. My rate of rise now is coming down nicely to 6.5. And so you now see at this stage that increased PA now helps me with the lower burner setting also to slow down the roast. This is why I love this machine in general. This is why I love these roasting software of the Giesen, because it really allows you to manipulate the roasting process to your liking, to your design. First crack is on its way, 374 degrees Fahrenheit bean temperature. I'm going to reduce my burner setting to the minimum 1%. And my rate of rise now is 2. Our roasting time right now is 9 minutes. So we have a nice, gradual, very controlled first crack. And so this first crack, of course, opens up the window of the roast development. So my first crack in this case started at 8 minutes 45 seconds. And when I take the beans out, that's when the roast development stops, of course, also. And then I can create that calculation of a percentage. And that tells me a number that I can also compare for consistency purposes. I don't want to bake these beans. I think they're done. Roasting is over, 395 degrees, 10 minutes, 15 seconds. And I do a brief inspection of these beans. I'm going to taste one. Ooh, very nice. I think we were successful. So we had a heat soak. Then we turned the burner to 80%, gradually reduce that down from 80 to 60 to 40 to 20 to 10 to 1%. First crack started at 8 minutes 45 seconds, end of the roast at 10 minutes 15 seconds. That's, if I put my mathematical mind to work, that's somewhere around 20% roast development time. That was what I had in mind for this roast. Next step is to cup this, and then we can really judge whether or not this was a successful roast. So let's do that.